Good morning, Param. Alright, let's start. Today's class is time value of money. We will start with what time value of money is, the basic principles of that. Adjust the video. Somebody is saying adjust the video. Just give me a minute. Is that okay now? Right. So today we'll be discussing about time value of money, the basic principles. Then we'll discuss about what future value is and what present value is. Right? These are the basic things that we'll be discussing, and we'll be taking as many problems as we can handle in these 2 hours before we move on to the next part of time value of money. So time value of money, again, in the introductory class that we discussed that $1 today is worth more than $1 in future, right? Why is that so? We said if we have this $1 today, if this is today and this is, let's say, in future, meaning let's say next year, if the interest rate is 10% per annum, this dollar will earn 10% interest in this duration. So this is today, right? This is in future, let's say 1 year in future. So this 1 year will earn, let's say, 10% interest rate. Oops, sorry. That's interest, let's say. This is 10% interest. So this $1 will earn 10% interest. So this future value will be this dollar plus the 10% interest, right? So that's why we say $1 today is worth more than $1 in future. This $1 can buy you a lot of things and compared to $1 here. This $1 today will be equivalent to more than $1, right? Because it is earning the interest. That's why this one is worth more than this one here. The one today will be equivalent to, or let's say 100 today will be equivalent to 110 in future, right? So if you talk about the figures, 100 here and 110 there. This 100 is equivalent to 110 there. So 100 cannot be equal to 100, right? So this 100 will be higher in value when compared to the 100 in future. That's why we say the $1 today is worth more than $1 in future, right? This we call it as time value of money. Money has got time value. As the time progresses or as we go back in time, the value of money changes. So sometimes we represent this 10% interest rate that I said, we call it opportunity cost, right? As we go further, we will also understand the different terminology that we use. So we also call it opportunity cost. So the opportunity cost of $1 in future is the interest. Opportunity cost meaning that is the interest that we are adding to this $1, right? So the interest we could have earned on $1 received earlier, right? So the $1 that we are having now, if we calculate the future value of the same $1, we are adding this interest to it, which is also called as the opportunity cost, right? There are a couple of questions here. If the Ravikant says, but if economy down, then it may down also. Any chances? No. See, what is happening is this $1 will still be $1, right? If the economy is down, then the 10% interest may decrease. So from 10% it may go to 5%, 4%, 3%, whatever. But you're still adding that percentage to this $1. Is that clear, Ravikant? And Santosh is asking, value may change from both sides, either increase or decrease. That's true. So from here, if we are here today and you're trying to calculate the future value of this, then it will increase. Right? Meaning, basically the value here is higher, so you're adding the interest part to it, so the future value in terms of figures will increase. When you're having, let's say 110 here, 110 in future. After, at the end of 1 year, you have 110. You want to know how much it is worth today. Next year, this time you will have 110. What is that 110 worth today? Meaning you're moving backwards in time. You're coming from right hand side to the left hand side. So what do you do then? Then you decrease this 10%. From this 110, you remove the 10%, that is the interest. Right? So then it becomes 100. So if you are moving from left hand side to right hand side, you are adding the interest part, which we call it as compounding. Right? The term that is used is compounding. Meaning you are adding interest to it. Interest to interest. If this is a scenario where you have 1 year. Right? I'll just clear the annotations. Right? Let's start again. Now let's say we have 2 years. This is the 0th year. This is the first year. And this is the second year. Right? So in that case, I'll come back to the couple of questions that I see here, but let me finish this. So today, end of 1 year, end of 2 years, let's say. So if the interest rate is again 10%, you have 100 rupees here. Right? You add 10% interest, which is $10 to 100, and by the time you come to the first year, it will be 110, which is 100 plus 10% interest. 10% on 100 rupees is 10 rupees. Right? So 100 rupees plus 10 rupees is 110 at the end of 1 year. Now, when you're coming to the second year, what are you doing? You're calculating again 10% over 10% over this 110. This 110 includes the 10 rupees, which is the interest. That is true, Santosh. 121. So 10 rupees, which is the interest that is earned between 0 and 1. That is earned in the first year. You're calculating interest on that 10 rupees as well. That's why you're calculating interest on the whole amount, which is the principal plus interest, which is the 100 plus 10, 110. On this, if you calculate 10% interest and add to it, then it becomes 121. Why? Because the 10% of 110 is 11. Right? 10% of 110 is 11. So 110 plus 11 is 121. Right? So as you're going further in time, from today to some day in future, you are adding the interest part, not only on the principal but on the interest too. Right? So you're compounding, we say. We are adding interest, we're calculating the interest on interest and adding to it, adding to the principal amount. That is called compounding. So if you're going in this direction, then we call it as compounding. I'm not writing the whole thing, it's hard with this annotation. So the same applies when you're going from future to backwards in time to present. So if you're moving in this direction, somebody gave you a future value of something, you want to calculate how much it is worth now. Right? So whatever that future value is, you take that future value and remove this interest part. Now 121 is the future value, you know. Right? So you remove the interest part. You remove this interest part to arrive at this 100 rupees today. Right? So when you're removing the interest part, then we call the term that we use is discounting. Discounting meaning from future you're moving towards present. Because you're moving towards present, we are removing the interest. Now why are we removing the interest? The simple logic is if you are having this 100 rupees, if you're utilizing those funds, or Then you add, for this duration that you want to calculate the future value, that means you're utilizing those funds, this 100 rupees for 2 years for something. That's why you have to calculate interest and add interest to it. But if you're not utilizing those funds, if I'm borrowing 100 rupees from the bank, right? If I want to keep those 100 rupees for 2 years, then I have to add interest to it because I'm utilizing those 100, I'm keeping it with me, right? But if the bank is giving me 121, let's say, how much did I invest? Meaning, I am removing the interest. If I am not utilizing it, what will be the value? So then you remove the interest. That we call it as discounting, right? So sometimes the same interest rate that we called as opportunity cost is also called as the discounting rate. So when you see discounting rate, interest rate, opportunity cost, all these mean the same thing, right? So as we proceed, we will see with this different terminology, we'll see a few questions. Then you will know it's all the same. So when you're calculating, when you're going from present to future, it is compounding. When you're coming from future to present, it is discounting. Is this clear? Is this concept clear? The terms discounting and compounding. Right, now I'll take the 2 questions. Srinivasan says, I think people are assuming dollar versus rupee. I'm not sure what the confusion here is, Srinivasan. Basically, you say rupee or you say dollar, it's all the same. But usually, the saying is, generally like few sayings. The saying is that dollar today is worth more than a dollar in future. That is the saying. That's why we just put a dollar figure instead of a rupee. Does not matter. It's still the same. You have a one rupee today or 100 rupees today. The value of those 100 rupees is higher and compared to the 100 rupees in future. So this 100 rupees today will be higher, meaning you add the interest part to it and then it becomes equivalent. 100 now, 100 at the end of next year will not be same. 100 now will be 110 next year. That is what it means, right? Is that clear, Srinivasan? And everybody else, are you getting confused with the dollar and the rupee here? It doesn't matter. The saying is $1 today is worth more than $1 in future, so that's why we have used this picture. Naga says, inflation related to the concept of time value of money as interest rate. Inflation, again, we'll see that part later on, Nagaraj, because here we're talking about interest rate. And when we discuss about the opportunity cost of capital, which is this rate, then we'll say what are the things that it will contain. Will it contain inflation rate? What all it contains? And we'll be discussing about it, right? So any questions in this first slide of time value of money? Do you all understand that $1 today is worth more than $1 in future? And why it is more? Because we have added the interest rate. And the same, the reverse applies when you're moving from future to today. Right? We discount, we remove. Right? So, Kadir is saying Srinivasan means rupee and exchange rate fluctuation. No, see, let's not go into all those things. We are talking about simple compounding and discounting, which is like a simple interest, compound interest thing that we are talking about, right? And here we're talking about compound interest, right? Let's not go into those bigger things. We'll go one step by one step. First class, you had a lot of questions, understood, because it's introductory class. But as we go, let us not mix up other concepts here, right? So as we go, it will become clear. The next, the same thing I've explained because the annotations were not very clear. Example, assume that you have 100 rupees now and the interest rate is 10%, right? So present value, 100 rupees now meaning at T0, if you can see this, can you see this? At T0, what you have is 100 rupees. At T1, the same 10 rupees, 10% interest, 10% on 100 is 10 rupees. So you add that, it becomes 110 at T1, right? So 10% on 110 is 11 rupees. So you add that, it becomes 121. So at the end of T2, you are having 121. So this $100 or 100 rupees today is equivalent to 121 in 2 years, or is equivalent to 110 in 1 year. Right? This terminology, what is it equivalent to? How much is it worth? These are the phrases that we use. So at the end of 1 year, future value is, how did we calculate, if you're only looking at this part here at the end of 1 year, how did we calculate 100 rupees, which is the present value, which is the principal. So present value at 100 rupees plus 10% of 100, right? 10%. R is here, the rate is 10%. So let's call the rate as R times PV, right? So 10% is the interest rate. 10% times 100 will give you $10, which is the interest, right? Now what are we trying to do? Why are we taking up the same example here again? Because we want to arrive at a formula. So from the example that we have already discussed and familiar with, we are trying to arrive at a formula for future value, right? So present value is 100 rupees. What will be the future value? 100 rupees plus the interest that is earned in that duration. So this part here, PV is the principal amount, and this part here is the interest amount. Together you will get the future value, right? So future value is equal to formula wise present value plus interest rate times the present value. So present value is 100 plus interest rate 10% times 100 is 10 rupees. So 100 plus 10 is 110. So that will become the future value. So now if you have to put it in a formula, PV plus R into PV. Those of you who are familiar with algebra, PV and PV are common, so we bring the PV out. And PV is 1 time here, so inside the bracket that is 1 time plus this is R times. So PV into 1 plus R, that is the future value formula. So this is something that you have to remember. So future value will be equal to PV into 1 plus R, right? When we are only considering for 1 year. What if we have 2 years? What if we have more number of years? Then the formula changes a little bit. How does it change? You keep doing the same thing again. Now whatever this is, that times percentage, that plus, that times the rate, right? So if you keep compounding that way, the compounding part, whatever is the number of years, that number of years will come in the power like this. So if the number of years is more than 1, then we say future value formula is PV into 1 plus R whole to the power n. N is the number of periods, number of compounding periods, or if it is the other way around, discounting. So when we say discounting, the formula will change slightly. That we'll see again. So here we are trying to arrive at future value formula. That is the future value formula that we are looking at, right? If there is only one compounding period, the formula will be future value equal to PV into 1 plus R. If the compounding periods are more than 1, right? More than 1, then it is present value into 1 plus R whole to the power n, where n is the number of compounding periods. Right? This is for future value. Now what happens to the present value? Now if the future value 121 is given to us or 110 is given to us, we want to know what it is worth today, meaning in T0 terms. T0 meaning now. Right? What is this worth? So we know that we have to remove. We have to remove what? The interest from this value or this value, whichever. From the future value, we have to remove the interest for that period, those periods, right? So again, if you go back to the elementary mathematics, what we teach students, how do we teach multiplication and division to students? right? As school children, how do we teach multiplication and division? We say repeated addition. If you're repeatedly adding something, then we call it as multiplication. Right? If you take two tables, I have a 2 plus, I have another 2 plus, I have another 2. So what is happening? I am repeatedly adding 2 3 times. Right? So then we say 2 times 3. So that is how we teach multiplication. Repeated addition is multiplication. Likewise, repeated subtraction is division. Repeated subtraction is division. So here what we are doing for calculating the present value, we are repeatedly deducting the interest part. Right? So that becomes division. Right? That's why when we calculate the present value, we take the future value. Here we are saying divided by, because we are removing the interest part, divided by 1 plus r to the power n. When calculating the future value, what we are doing? We are adding the interest part. That's why for the present value, we are multiplying this 1 plus r to the power n. Is that clear? Future value, we repeatedly add the interest. That's why present value multiplied by 1 plus r to the power n, because we are repeatedly adding this interest part. Likewise, when we calculate the present value, we repeatedly remove the interest part. So we say divided by. So that comes in the denominator. The future value divided by 1 plus r to the power n. That is the formula for present value. Now let's pause, understand this. If you have any questions, ask me. Present value, future value. Before we take up any questions, please understand this and let me know if you have any questions. Alright, Param and Kaderi says clear. Thanks for that. Yeah, Chetan also is saying clear. So let's proceed. There's one question here, Ashwini. How future value will be calculated or varying? If it is varying, we will look at it. Ashwini? So for now, just to give you a brief idea, like I said, all these concepts are dealt separately. So there is no overlap and the concepts are clear. That's why we'll take one step at a time. But again, just to give you an idea, if here the interest rate is 10%, let's say, and the second year the interest rate is 15%. So for this value we calculate using the 10%, and then whatever future value we get, we take that future value and use 15% to calculate the next year's future value. Right? That is how we do. But unless we take up an example and do it, probably it may not be clear to some of you. That's why for now, leave it at this. When we come to varying interest rate, we'll take a couple of questions and we'll try and solve them. Okay? Nagaraj is saying, should we not always say future value of a present amount is with respect to a timeline? That is not, that makes sense if you want to clearly specify. Right? But we generally say future value 121. Right? When we say that, if you're talking about a particular question, we do mention the timeline. Right? We'll take up a particular example of a timeline. Now when I say someone promises you 10,000 rupees in 3 years, right? So that is what we are saying. So like you said, Nagraj, we are saying 10,000 rupees in 3 years, right? So if I am saying, Nagraj, I will give you 10,000 rupees in 3 years, but I need some money. Can you please give me money now? So then, but can you please give me equivalent money now? Meaning, you will use whatever is the interest rate. You know that future value 10,000 is going to come in 3 years' time. right? Whatever is the interest rate, you have to deduct that interest for 3 years to get the present value, right? So every time, whenever there is a question, we normally talk about the future value in terms of time, like you're saying, with respect to time, in 3 years, in 5 years, in 10 years, whatever is the time, right? We do say that. Is that clear, Nagraj? Now, whenever we start these future value and present value calculations, it is always advisable to get the timeline set up correctly. If the timeline is set up correctly, then it is very easy to calculate, and 90%, like it's said here, 90% of the time you will get the answer right. It's not about the answer, but you know how to solve it, and you know how to arrive at the right answer, right? So get the timeline right. That is the first and foremost important thing in future value, present value calculations. Now, how do we set up a timeline? That also we have to learn, right? How do we set up a timeline? You draw a line. Now, meaning present value today is always 0 or time 0, t0, however you want to represent, right? If you say next year, it is 1. Year after 2. So if the question says for 3 years, for 5 years, set up so many vertical lines, 0 to 5. Question says 3 years, 0 to 3. Right? Like that, so many vertical lines. And these parts here is what is the cash flow. Right? So CF0 is the present value. CF1 will be CF0 plus the interest on CF0. CF2 will be CF1 plus interest on CF1. Likewise, those are the cash flows. And sometimes you have to be careful when you say that. Sometimes you get, when you talk about problems like monthly installment, right? EMIs. Then this CF0, CF1, CF2, CF3 all will be the same. These payments, as we call it, monthly installments, monthly payments as we call them. When you talk about installments or these payments, the payments will be a fixed figure, right? Inside that, meaning if you have taken a loan of 10 lakhs, the EMI that you pay per month, let's say you are paying 20,000 as EMI, right? So the 20,000 EMI that you are paying will be same. If you are taking a 10-year loan, each month for 10 years you will be paying 20,000 per month. Then what is that we discussed in the previous slide? In the previous slide we said here it is 10%, so 10% on 100 is 10 rupees and 10% on 110 will be 11 rupees. So these interest amounts are differing, right? Then when we talk about the payments, why are we saying they are fixed? They are fixed because each of those payments, each of those EMIs will have a principal component and an interest component. That component within that payment will vary. If I am saying 20,000 per month is the EMI that you are paying, so first month when you are paying, your principal component may be 1,000 and 19,000 could be your interest. Right? Second month when you are paying, your principal component could be 1,100 and 18,900 would be your interest. And likewise, if you are taking a 10-year loan, from the first monthly installment to the last monthly installment, your principal component keeps increasing slowly and the interest component in it slowly decreases. It keeps decreasing as you move from the date you have taken the loan to the maturity of the loan, right? So within that there will be a principal and interest which will vary, but as such the payment will be fixed, right? Again, that's a different concept. When we take a loan problem, if you are all interested, we can solve one, then we will understand that. So for now, how do you draw a timeline? You draw a line, start with a 0, which is the present value. Whatever is the present value, put that figure in there. Whatever is the interest amount, interest percentage, write down that interest percentage, I%, meaning 10%, 20%, whatever that percentage is, write down that. How many years or compounding periods that you have, mention that. 1, 2, 3, 4, whatever that is. This is how you draw a timeline. Right? So every time as we are discussing a problem, I suggest please get a notebook and a pencil or pen, and as we are discussing, make a note. When I am reading out the question, or when the screen, you can look at the screen and read out the question yourself and draw a timeline before you even start solving it. Right? So let's take a small problem. Now, if you're all ready with your sheets of paper or a book and a pen, try and draw a timeline. What is the future value of an initial $100 after 3 years if I is equal to 10%? Just to draw a timeline. Ready? Ready with the timeline? Have you all drawn the timeline? 0. 3 years it is saying, so 1 year, 2nd year, 3rd year. Right? 10% is the interest rate. I or R, whichever way you want to represent. Don't get confused with I and R. I like to put it as R. So I or R. So 10% is the interest rate. Future value of $100. Initial $100, meaning that is the present value. $100 is what you have at 0. Right? Now you have to add 10% to it. Then whatever you get, add 10%. That is when you do step by step. Right? But if you're taking a loan for 20 years, 30 years, you can't sit and calculate for every month or every year, right? That is why we have the formula. The future value formula is future value equal to present value into 1 plus R or I, as you want to call it, I to the power n. Right? So present value is 100 into 1 plus R. 1 plus R. And one thing that you have to remember here is, whenever you are saying interest rate in percentage, when you are using that percentage value in your calculations, you always convert it into decimal. Right? So the 10% when you convert it into decimal is 0.1. So 1 plus 0.1 to the power, we have 3 compounding periods here, so to the power 3. Right? So 100 into 1.1 to the power 3. Now 1.1 to the power 3 is what we have to see, and then multiply it with 100. That will give you, most of you have it right, I think, 133. Right? This is if you are used to calculating it. What if you want to use Excel for that? I am just trying to share my screen. Just give me a minute. I'll see how I can share. Can you see my screen? Can you all see my screen? You're not responding. Can you see the Excel screen that I have opened? Yes, Anil says yes. All right. So you can see. So basically what I'm trying to show you is, if I have 100 here, This is my present value, and I have R, which is, let's say, 10%, right? 10% is 0.1. Oh, sorry. 0.1, right? I want to calculate what the future value is, right? Future value will be, I can use the formula equal to, I can go here and say what is that I'm calculating? I want to calculate the future value. So, future value is present value into, you know the formula, right? Present value into 1 plus r to the power n. So, the same thing if you calculate, there is a present value function in Excel. Present value function, you have to give rate first. What is the rate? Rate is 0.1, comma. You also have to give n. Sorry, I forgot to write n here, but for now, let me write down. Alright, I'll write down here. Doesn't matter. I'll write down n here. N is 3 years. Sorry. 3 years. Now, equal to present value function. Rate is 10%. N is 3. Right? PMT, F3, all that you can ignore because there are no payments. We are not calculating monthly or whatever the fixed payments here. So we only have one sum, one amount, which is 100 rupees, for which we want to calculate what it is worth, right? What it is worth in future. I will come to it. I'll come to the payment part. That is our next session, which is maybe tomorrow. So this is all we have. Now what? Sorry, I entered something wrong. Then this is also a mandatory field, right? That's why I didn't accept. Let me see now. Oops, something wrong. Just trying to give something. All right. Sorry guys. I'm not giving the future value there. That's why it was not taking. Right? So that's what it is. So basically, what we are trying to do here is, we are calculating the future value. So we are using the future value function because we want future value. Multiply, then you take the rate. Rate is 0.1. N is 3. And if you have amounts which are fixed amounts, which are like EMIs, then you mention that amount or you pick up from here. You can also give the cell address. So right now I have just given the amounts. I'll also show you the cell address. But PMT, which is the payment, we don't have. We only have one single sum, which is 100. Right? And that single sum is what? That is the PV. So you give the PV value. So the PV value here is 100. Right? So these are the 3 mandatory things that we have to give for calculating. Right? So if you give now, it is 331. Did you all get the same? How can it be 331? 133. Yeah, 133 should be the value. Why am I getting more? Did I use the wrong function? Let me see. No. Hang on. It's been a while since I've used Excel here. Somebody is saying payment is 0. If you mention payment 0, you'll get the right answer. Let us see. Let's just try that part. Yeah. Thanks for that. So what it is the future value. If you look at the formula, there is a rate here. The rate is what you have to specify the interest rate. N is number of periods, compounding periods 3. PMT, because that is a mandatory one, you have to have some value there. That is what I missed. So please don't make that mistake. It's always good to make mistakes when we are practicing, so we don't make mistakes in the final. So PMT is a mandatory one. How did I know it is mandatory? Because it doesn't have the square brackets around it. If there are square brackets around it, then we know that we can skip it. It becomes an optional parameter. But this is not optional. You have to give you have to specify some value. That's why I did not get it right the first time. So R is the rate. You can specify 0.1, or you can also say the cell address. Comma, N is 3. I can specify 3, or I can say cell address. Comma, PMT, we do not have payments, right? There are no payments here because it's only one single sum. That's why we are saying we don't have that, so we are saying 0. And the next is present value. Present value we are giving the cell address and close the bracket and say, so it will give you 133.1. Is this clear? We have done slowly. We've also done a mistake. So we all know what mistakes can be done when you're using this function, right? So what is the mistake here? The mistake is when you're using the formula, see which ones are the mandatory or the parameters which you have to give, and which are the optional parameters. Optional parameters, I repeat again, will be in square brackets, right? That you can skip. If you skip that, the function will not have an issue. But if you skip any of the other ones, it will not give you a right answer like we have seen, right? So these three you have to specify. If you do not have a payment, say 0. You are calculating the present value of a lump sum value of 100 here, right? So this is how it is. So now we'll just make it clear. Right? So this is what it is. This is the future value calculation. Is this clear? Right? So we'll stop this. Any questions in this? We'll stop sharing this and we'll come back to our calculation. Alok is asking. Alok has got the same question which normally most of us get when we are trying to understand the present value, future value for the first time. So I'll go back one step again. And Alok, what you're saying here is 10,000 rupees 20 years ago or whenever is a lot higher when compared to 10,000 rupees in or today. Right, that is what you're saying, which is what exactly we are saying, right? So that is what we are trying to understand. Why is it low? 10,000 rupees back then is a very high figure. You could buy a lot of things with those 10,000 rupees. The same 10,000 rupees, if you have none now, you cannot buy all the things that you bought back then in 20 years ago, right? Why is that? So what we are saying is this 10,000 rupees back then is the same 10,000 rupees. Now here you are comparing the same 10,000 rupees with 20 years ago value, 20 years ago figure, right? That is not what you should be comparing. What is this 10,000 now? After 20 years, the same 10,000 will be 10,000 plus the interest accumulated for the last 20 years. So this 10,000 rupees now will be much higher in terms of figure value. But in terms of worth, Meaning what you could purchase with the 10,000 20 years back and what you could purchase now, the amount, the 10,000 that you have back then is much more valuable. Right? Now, if you are taking the same figure 10,000, it is not same, it is not equivalent. The equivalent will be 10,000 plus all the interest, the compounding interest that you would have accumulated in the 20 years. That would be the equivalent value. Right? Does that make sense, Alok? Right. So what we are saying is, when we talking about worth, the worthiness of this figure 10,000 or 100, whatever the figure is, the worthiness in present terms, the worthiness is much higher when compared to the same figure worthiness in future. So there are two things here. One is the worthiness, one is the figure value. Right? If you are comparing two figures, same figure, one in present and one in future, the one in the present will have more worthiness when compared to one in future. To make it equivalent, you have to add the interest, right? That interest when added becomes equally worthy when you compare the two figures in the timeline. That is the present value and the future value. In the present time and in the future time. When you are calculating and comparing the figure, if you say same figures, they are not equal. How can they be equal? If this figure to this figure, if you add the interest and make it bigger figure, then they become equivalent. Right? So that is what it is. So the present value, the future value that we calculated in Excel, is that clear? Is that clear? Any questions there? Santosh is saying, for me it is minus 133.1. Santosh, it is actually minus 133.1. You brought it up very nicely, very good. I wanted to bring it up. I was waiting for one of you to ask me. Guys, did you all try in Excel or did you all use in financial calculator? Did you all calculate this in financial calculator or Excel? Did you see that we get a minus figure? When I was showing you, the 133.1 was in red and in brackets. You didn't ask me why is it in red and why is it in brackets. So in Excel, if the value is in red or in brackets, then it signifies that it is a negative value. Minus 133.1 is what was showing in Excel. And I'm pretty sure it will show the same in financial calculator. Why is that? Santosh brought it up. Why is that? Now all those of you who have done calculation using the formula, I'm sure you would have all got positive. So no issues there. So you wouldn't have realized. Right? But if you use financial calculator or Excel, then it shows negative. Why does it show negative? Is because whenever we give the present value or whenever we give the value for PMT that you have seen, I'll show you again, the PMT, now the figure here, did you see it was in red and it is in brackets? That signifies that it is a minus 133.1, right? So why did we get minus 133.1? Because we gave present value as 100. So whenever we talk about present value in the formula, see there is a PMT, right? There is also a PV. So for these two, PMT and PV, whenever you give in the financial calculator or in Excel, you have to always specify it as minus. Right? These two values have to be specified in the, if you are using Excel or financial calculator, mind you, only then. Right? You have to give it as minus. Then you get the value as, then you get the value right? This value will be automatically changed to, this value 133.10 will automatically be changed to positive. Is that clear? Right? All the future values will always be shown with a positive sign in financial calculator and Excel. All the present values or anything that is back in time, be it a payment or one lump sum present value, you have to show it with a negative sign like I've shown here. If you show it with a negative sign, you get the future value in positive. Right? When you're doing calculation using the formula, there's no issue there. But the way it is set up in these two things is that present value as well as payments have to be given with a negative sign. Right? Remember that. If you get a negative here, don't worry. When you may be using Excel, but in the exam, you just pick up the future value and show it as an answer if you want to show it that way. Then you show it as positive 133. Just remember that. Right? If you are happy using the formula like I do, I generally don't use Excel, that's why I took some time. But if you're happy using the formula like I do, no issues there. Right? So, right? So Ashwini, is it clear to you? Why negative? All the present values, all the PMTs which are in back in time, we always show it with negative. That's only representation, right? You don't have to understand. It is just a representation that we show, and that is how it has been set up, and that's why we give it with a minus sign, right? Similar to this, we do the present value calculation as well, right? When we do the present value calculation, also the same thing happens, right? We'll see that. But I just want to break it for a couple of minutes. But before I break, I want to give you one question and I want you to solve in the break, or let's see if we can jump to the slide. Hang on. Right. Can you please try and solve this using the present value formula? That's right, Nagraj. That is the convention. See, Nagraj is clarifying from accounting perspective. Generally, any cash outflow is shown with a negative sign. Right? Any cash inflow is shown with a positive sign. That is why we show it that way. Right? But when we come to NPV calculations, then you will understand. Since most of you do not have accounting background, some of you at least, I would say. So I don't want to confuse you with terms cash outflow and cash inflow. But as you proceed further, we will try and do the project selection. Right? When we do the project selection, we have multiple projects. We will apply this formula and we'll calculate which is the good project. Right? Based on its NPV value. That is when we'll discuss what are the cash flows for the year and what is the outflow and what is the inflow. Right? Then you will understand why it is. We're taking one step at a time. If few things I'm saying, just remember, please try to remember at this stage. That does not mean we won't discuss it. We will discuss it at the appropriate time. There are so many things that we have to discuss as we go further. Right? And at the end, again, we will at midterm and also before the final exam, we will do a small revision. Then you will know. All that if we missed out something discussing, then we will discuss again. Right? Okay, somebody is very quick here in giving me the answers. I am not discussing the answers. I am just breaking few minutes. I'll stop the recording.